All right. Limit as x goes to 0 of tan 3x over x equals, we've got 0, 2/3, 1/3, 3, and does not exist. So I'd encourage you to copy the problem, try it, make your guess, and then we'll go through it. All right. So the right answer here is we've got some properties of special limits that we've got to remember, and one of them is the limit as x goes to 0 of the sine x over x, and this one tends to show up quite a bit, is 1. And if we plug that in our calculator, we can see that there's a hole at 0, but it has a limit that exists at 1. So when we see things like this, we typically want to try to get something like this. So there's usually a pretty, kind of a straightforward way of getting there. Tan we know is sine over cosine. All of that over x. Now I can break up this fraction into 1 over cosine 3x times sine 3x all over x. All I've done is kind of broken up that numerator. Now I can also break up this fraction into, like, kind of almost pretend like there's a gap here and there's a 1 times x here. I can make it 1 over cosine 3x times sine of 3x over x. And now we're actually getting very close. In any fraction ever, I can put a 3 here, and I can put a times 3 here. We can always just multiply top and bottom and it doesn't go away. Now I'm there. Now I can find the limit as x goes to 0 of 3 over cosine 3x times the sine 3x over 3x. This is from our initial definition. That is 1. The cosine of 3 times 0 would be the cosine of 0, which is 1. So 3 over 1 is 3. So our right answer would have been D. All right, let's take a look at this one. Tank contains 60 liters of water at 3 hours. Water is being drained out of the tank at a rate of R of t, which is what we've got in our table. Select the values of R given in the table above using a midpoint Riemann sum with 3 subdivisions and the data from the table. What is the approximate number of liters of water that are in the tank at time t equals 15 hours? All right, so I think the first thing you got to do is you got to sketch that graph a little bit.
Should we make a pie graph?
From 3, 5, 7, 10, 13, 14, 15. Now, like, intervals don't matter. Obviously, my scale is not great. We really just want to demonstrate 3.7, 3.5, 3.1, 2.9, 2.8, 2.6, 2.1. The key to this problem is we want midpoint and we want 3. So once you draw it out, you should be able to see the 3. There's 1, 2, 3 good divisions. So then our midpoints are going to be here, here, and here. So we just find the area. We've got a base of 4 here, so it's 4 times the height would be the 3.5. Let me get a better color there. Plus 6 times 2.9 plus 2 times the 2.6. Now this is no calculator, I believe. So we could definitely do it with no calculator. That all adds up to 23.4. No. That all adds up to 36.6, which is an option. but it says a tank contains 60 liters of water and it's being drained out, which means we've lost 36.6. So the interpretation of the problem is important. So 60 minus that, that's where my 23.4 comes from. And that's going to be B. All right. I think we got number 17 here. We'll let f be the function defined for what value of m is f continuous. So for them to be continuous, they would have to be equal. So let's take a look. When would that be equal to m? Right now we can't put the -1 in as far as our substitution goes. So we want to try to factor. The numerator there factors into 3x plus 1 and x plus 1 over 4 times x plus 1, which means we had a whole where x equals -1. So now I can put the whole in. So when x is -1, I get -2/4, which would be the value I needed m to be for it to be continuous. All right, what is the area of the region in the first quadrant bound by the coordinate axes and the graphs of y equals e to the 2x and x equals 3? So let's graph that guy. First quadrant, coordinate axes means x equals 0, y equals 0. And the graphs of e to the 2x and x equals 3. So this point here would be 3 comma, I don't know that really matters, e to the 6. So area under the curve, top minus bottom. The integral from 0 to 3 of e to the 2x dx. The integral of e to the 2x is e to the 2x divided by 2. That's that anti-chain rule from 0 to 3. If we put the 3 in, we get e to the 6 over 2. Minus, if we put the 0 in, minus 1 over 2. So we can factor out that 1/2. Looks like we get 1/2 e to the 6 minus 1. All right, we've got a function defined by f of x equals the square root of the absolute value of 4 minus x. For all x, which of the following is true? Well, let's graph that guy again first. Now, at x equals 4, something happens. And let's see what that is. Normally, this would be an upside down. So if x is 4 and above, we're really just graphing the square root of 4 minus x. Actually, if x is 4 and below. So that should look like the square root, really. And then because of the absolute value, that's just going to reflect it and allow us to be defined over there as well. So it is going to be continuous. So that one's not right. Differentiable is always the key. Anytime we go like this and like this, we're going to have a cusp. So it's not going to be differentiable. The limit as x goes to 4 does not equal 0. Well, it definitely equals 0. X equals 4 is a vertical asymptote. There's no asymptote. F is continuous, check, but not differentiable, check. So it's got to be E. All right, using U substitution, U equals x squared is equivalent to which of the following? So if U equals x squared, du is 2x. And if x is 1, u is 1. If x is square root of 2, u is 2. So that's going to be our limit change. And then I need a 2 here, which means I need a 1/2 here. So it's going to be a 1/2 integral from 1 to 2. There's my du e to the u. That looks like A. Good. 5 multiple choice questions done. All right.